I see the last two tapes I did were about 30 minutes, and that's a tad long, but there's lots of stuff to cover, and again, it's a good review. So we're going on now to topic 4, Introduction to Curve Fitting, Point-Slope Form. Well, we had said there was one equation we hadn't done yet, and there it is, right there. This was equation 4, which is called the point-slope form. And we'll be doing some of these things as we go on. So let's raise that up, and let's see if we can put our 6 items of matching in there. You can pause the tape. So again, this equation, we're calling this equation 4. Oh, that's the point-slope form. Now within this equation, the letter M right here refers to the slope. And this y sub 1 and x sub 1 is the point that we know. So we know the point, at least one point, and we know the slope. We put it in this equation, and we can get an equation out of it. Now, another thing we're going to be doing is, here we've made a little graph, and this was the data we collected. And as we look at points along the graph, we could actually get some values. Now notice there's a trend, and the line is not going through every point. We are doing what we call linear regression, which is sort of averaging our reading up here. Now notice up to this point we have data. So when we are picking data out of this area, we are doing what we call interpolation. Interpolation, estimating a value between known points. Now, if we extend this trend up into areas we don't know, we don't have data, but extending that trend, that pattern, we get what is called extrapolation. So we extrapolate beyond known data, and we interpolate within known data. Okay, so there's sort of a nice review of what we're going to be doing. So in example 7, it's asking us to find a graph or an equation using the point-slope form, in which we have the slope of 2 and the 1 point, -3, 1. So there's formula 4, and I'm going to substitute. Now my y sub 1 is a 1, so in the formula I put a 1 there. My x sub 1 is a -3. So in the formula, notice I've put it in parentheses because there is a negative in the formula, and watch what happens. The opposite of a negative will make this a positive. So we'll need to keep that in mind. And I put in the slope. So now my next step is to get rid of the parentheses. So this becomes y minus 1 equals 2x as I distribute. And now 2 times a +3 gives me a 6. I'm going to transpose this -1. It becomes on this side a +1. And now I have the equation y equals 2x plus 7. Now notice they also want us to graph this new equation we found. So we can go right here at our y-intercept, which is a positive 7. We have to kind of sketch that in because there is no 7. And our slope is a 2 over 1. So we're going to go over 1 up 2. And this is strange. They gave us a number like that. And we put our line in there. So it'll be something like that. Now, another way to do this, by the way, and I probably should have mentioned this earlier, if they didn't want the equation, well, maybe I'm reading too much into this, but we could have just taken this point, a -3 and a +1. So -3 and a +1 would be right about there. And then from that point, it's over 1 up 2. So actually I was pretty close, and that would have been the line. But filling it in, and let me look at what they give us here in the book. Actually, I think all they wanted us to do here was this one. Okay, I'll have to watch the answer column a little bit better. And on this one, I'll stick to the program. All they're asking us is to substitute this information into our PointSlope form. So again, this is basically how you're going to leave it. Notice that our y is a -6. So our y value is going to become positive here when we take it out of this form. But now when it's in this form, we can plot this very well. Our point is 4, -6. So 4, and then down to -6 is right there. And our slope is a -1/3. So that means we're going to go over 3 this way and up 1 this way. So our line will be like so here. That's the graph of this. All right, for these, now they have substituted into the PointSlope form the slope and the point. But what we are to do here is to pick out what is the slope. Well, the slope of this one is 1/5. The slope of this one is a -3. And the slope of this one is 6. Now, what's our x sub 1 and y sub 1 values? Well, if you notice, in order to get a -7 here, we had to have y minus a +7. And in order to get a -2 here, we had to have x minus a 2. So our ordered pairs, if you look at it as you see it, there's a -7, but our original ordered pair coordinate was a positive 7. And our original ordered pair x value was a positive 2. So a little shortcut, if you see it in slope-intercept form, to find out what was the point that they're using, it's opposite signs. So if this is negative 7, it was a 7. If this were negative 2, it was a 2. So this is going to be a negative 3. Opposite signs. And this is going to be a positive 1. This will be a negative 5. Opposite sign, a negative 1. So if you were to put this information back into your point-slope form, equation number 4, this is what you would get. This next one's a little tricky. Notice it's y equals this, and you might say, is that in point-slope form? What would the ordered pair be that it's going through? Well, remember, if there is no b, your b is the origin. So there's your slope, a negative 2/3, and if I put a 0 there, and a 0 there, this just becomes a y, and this just becomes a negative 2/3 x, which is what we have up here. So this is sort of a unique one that they could try to trick you possibly. Put it in point-slope form, would look like this. But if you see it then like this, what was the point the line went through? It went through this, and this was your slope. Okay, so for this one, this is the same way as I did the first one. I overdid the first one, but this is what they want now. They want you to take this single point and using this slope, find an equation that's in slope-intercept form, right there. So it'll be y minus 1 equals 2 times x. Now minus a minus makes this a plus 1. So we get y minus 1 equals 2x plus 2. Y, I'm going to transpose the 1, and that becomes 3. So my y-intercept is 3. My slope is 2 over 1, so I go over 1, up 2, and there's my graph. And arrows on each end. Now I'm speeding this up a little bit. There's our slope and the single point. So when we put it in the point-slope form, our negative 3 here becomes positive. Our negative 2 becomes positive. There's our slope. I clear parentheses. Notice the 2's over here cancel out. There's a 1 left there, so that's where it becomes a negative 3. I transpose the positive 3 to this side, making it a negative 6. There's my y-intercept, a negative 6, 0. My slope is a negative 3/2, so I'm going to go 2 to the left, up 3, and there's my line. All right, here's a case where they're giving you 2 points and no slope. So we can use formula 3, which is the slope formula, which I've used here. 3 minus 6 over 1 minus 3 gives me a negative 3 over a negative 2, which becomes a positive 3/2. And I could use either of the points. I chose to use this set. So it's y minus 3 equals 3/2 times x minus 1. So there's the negative 3, there's the negative 1, because of the negative being in the formula. I multiply through, and I get this, and then I transpose the negative 3 to the other side. Well, on the other side, it becomes a positive 3. But in order to integrate with this fraction, I need to make that 3 over 1 into 6 over 2. So I could actually do my subtraction here. So negative 3 and a positive 6 gives me a positive 3/2. And there is my answer. Now this one's done in a similar way. I'm not going to give you any on your tests that are this difficult, and you shouldn't have any like this in your homework. And the answer is in the text. If I do every single one, again, the tape's going to be too long. I want to do this to give you an opportunity to see how it's done in action. Okay, as we look at example 17, we see there are, again, 2 points, and we don't have the slope. So I put that in formula 3, which is this one here. M equals, and then eventually notice you have the opposite of a negative made that a positive. So our slope then is 4/3. But did you notice this? This is your y-intercept. So your b here is 4. If you're lucky enough to get one like this, and by the way, this is your x-intercept, but that doesn't help you with the equations. It's only the y-intercept, because that 4 goes right there. And they are asking that we put this in function notation. So instead of a y here, we should have put this. Now, this one's a little tricky because of all these negative signs, but I set it up here for you. And then notice that these become a plus. So I have a negative 3 and a positive 7, that's 4. A negative 1 and a positive 5, that's 4. And 4 over 4 gives me a slope of 1. That when I had to choose either of these points, put it into formula 4, with our slope 1, it comes out to this. Now again, I'm not going to show you every single one. If you are finding you have problems, be sure to come early or stay a little bit after class, or when we have some hands-on, to ask these questions. And I'll be pleased, and I know over at the Tutorial Center on the 5th floor of the library, they're very happy to help you there as well. Now, for this one, they're giving us this table, which lists the total amount spent on nursing home care in the U.S. for several years. Using the data in the table, draw a graph. Then estimate the amount spent on nursing home care in 1997 and in 2003. Okay, so I'm going to move this up and to start working on our graph here. And you could do that as well. Okay, and looking at number 19, just to go over some of the pointers on the graph, that down here, we're indicating there's a whole lot on the bottom that's missing. And then we're starting here at 60. So every 2 bars, 10. And then these are our dates down here starting in 93, 94. So this goes up to 2003. We only have data though to 2001. And I've sketched the data in there. Again, these dots aren't exact, but you can see that I took a line and sort of went through and averaged. This is called linear regression. And then they asked us, well, what would you would have expect that was spent in about 1997? And you go up and you say, well, again, my graph may not be that accurate, but about 82 billion, because you're going up there and then kind of going over there and reading it. I may be a little bit off. And then they're saying, well, how about in maybe 2005 or 2006? Now, we don't have that data. Keeping in mind, when you are reading from known data, that's called interpolation. When we extend the data, and if it keeps the same pace, then that's extrapolation. And the book is giving us this as an answer. Okay, again, you're not going to have anything like this on your test, but you should know how to read it. If they give you this example, you would have to read it. And by the way, on your math lab, hopefully you've already picked this up, there are little buttons where you can increase it a little bit, decrease it a lot, and really make it big so that you can see things and pick things out of the data they're giving you online. All right, now we're not doing those other two, but here in number 22, they're asking us to determine whether this data appears to be linear. And again, part of the test is, can you sort of make a straight line out of the data? And the answer is sort of. So we would say that number 22, this data is linear. Now, when you look at 23 and you start to look at the data and you start doing the line, does this data seem to be linear? And the answer is no. Okay, that's about as far as we're going to do. We're not going to do any more of this chapter. When you get to Math 105, by the way, 2.5 is included in that. You'll do a review of these others, and then they will present 2.5. But in our curriculum, in our homework, and on our test, we won't have any of these for section 5. So this completes our chapter 2 work. Get ready for your test. Remember, your testing average is a result of the raw score on your test and averages with your QuizMe. So if you have a high score on your QuizMe, that will pull up your test average. If you have a low score on your QuizMe, that's going to pull down your test score. Again, this is something I'm using this term. It's written up in our syllabus, and it gives you great motivation to have your homework done by testing time.